Roro. What in the world? Interesting. I don't know what's supposed to be in there. Oh, I bet I can guess it. What was in the one that's blank? What was in that one?
I got no idea.
Was it just an X? No, you should have. Did nobody write literally what I said to do? Was there not one there? Was it blank when it was up there?
Yeah.
Oh, it was. Oh.
What if you press the little undo button?
I did. Apparently, I had already erased. Yeah, it won't go back because then it just brings up all the stuff that was over here, but that still was blank.
Oh.
So I must have hit erase before. I don't know what I did. It was a fraction, I'm pretty sure, though.
No.
Yeah, so we'll go with that. All right, so here's your quick, super fast review because we have new material that is on, and it's going to take a little while to go over that. It is on the big quiz, although I did make it a little bit easier since we're only going to do it in 1 day, day and a half. The first thing you need to understand, and again, the quiz is done, so I'm telling you basically what's on there. You need to understand what is an exponent. What do we say an exponent was? Tells you to do what? First of all, we never multiply the base times the exponent. So this is the exponent, this is the base. We never multiply those two together. Never, 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 never. There's no situation. That's not what an exponent tells you to do. Don't ever do it. Even as a last resort, don't do it. It's completely wrong. So don't ever do it. So what do we do then? If we don't multiply them together, what's it tell us? How many times do I multiply 11 times itself? So the 3 says, take that 11, always multiplying if we're talking about exponents. Oh, well, the bases are being multiplied. And you do that. That's what it means. And again, there's no solving. You won't need to do any math, like multiply that out on the quiz. You just need to understand what things mean, or you need to be able to add exponents or solve an equation using the exponents. But you'll never have to multiply bases out on the quiz. So then what does the next one mean? Guys, yeah, it's the same thing. Everything in parentheses is the base. So if there was more stuff in the base, then we would write everything in the parentheses, which we'll get to one. But if there's not, if there's just the one thing, then it's that thing times itself, however many times as you have for the exponent. I think I'm recording, right? I don't remember if I'm recording. Yeah. All right. So those are pretty easy. Oh. What does this next, how would we, first of all, we'll go over what it means. What does it mean? 2 to the 5th and then all that raised to the second power. It's the same thing. Whatever's in the parentheses is the base. This is the exponent. Now we have an exponent in the parentheses, but that's fine. That can be part of the base. So we take 2 to the 5th times 2 to the 5th. Twice. So it means the same thing. Don't worry about the fact that there's exponents in there. It doesn't matter what's in the parentheses. If all that's being raised to a power, we just multiply it times itself over and over again. Now we learned the rule, 2 rules actually, that allows us to then combine that. So the product rule says if we are multiplying terms that have the same base, and this is from your sheet, so I'd have your sheet out today and we'll use it a little bit. We write the base. That's the A. It was this rule right here. That was the rule. So we saw that there was multiplication in our problem. We find the rule that has multiplication, and then this side tells us how to solve it. So it says to take the bases and add them together. And then that would give us 2 to the 10th. But what else could we have done? Well, that's what we did, 2 to the power of 5 2 times. But there's another rule that we could have actually just used at the very beginning. Again, if you're not using your sheet, don't expect to be able to use it on the quiz, the big quiz, the 100-point quiz. A lot of you need to do well. So I'd have your sheet out. I'd practice it right now. So pull it out. I'll give you a minute, pull it out. Right. Yeah, I don't have any extra copies anymore. I gave out probably 50 extra copies after I'd already given them all out. So how you keep losing them, I don't know. Next year I'm going to require people to lose them. What's it say? We could have used one of the power rules. Really, they're both kind of the same, we said. But in this case, it would be power of a power because there's only one base. So we could have used that rule. And what does that rule say? That's what it looks like. What's that mean? I'm going to go with cat. What's that mean, cat? It's the right rule. We found the right rule. Because we had a base with something and then raised to another exponent, so they look just alike. But what is this telling us to do here? Yeah, that's multiplication. This doesn't mean just write the two numbers next to each other. I'm not going to write 52. It means take the 5 and multiply it times the 2. Mn is m times n. If you haven't written that on your sheet, you need to write that on your sheet. So I had some people write the two numbers just right next to each other. That's not what it means. You need to take the 5 and multiply it. So we'd still write the base, by the way. So the base was just the base. We always just write the base. And we could have said 5 times 2. And you'll notice that gave us the same exact answer, which it better, as when we did it the other way, when we broke it out and used the product. So I don't care how you solve that top section on the quiz. Again, top section looks pretty much like the exit ticket one you just took last week. But you need to show your work. So either show that you broke it out and then that you added them, or show that you knew to just multiply them together, and that got you the final answer. A lot of people weren't showing their work, and I didn't take off a whole lot for that on the exit ticket. I will take off on the quiz. It very clearly says show your work, and it also very clearly says do not leave a negative in the final answer, and a lot of people left the negative in. What does this mean? Not really equals, but what's that mean? Halo, what's that mean? X to the third. Yeah, it means the base, which in this case is a variable, but that's fine. Doesn't matter if the base is a variable. It means that base times itself 3 times. I'll come back to that one because it actually deleted something. What about if I had this? What if I had that? What does that mean, Lupita? Not solving, so you don't really need a rule. You just need to know what that means. It means the same thing as all the other ones. What's the base in that problem? It's everything in parentheses. All of that stuff in parentheses is the base. It doesn't matter that you got numbers in a variable. That is some number. I don't know what number that is, but if I knew what x was, I could multiply x times 2. I could add 7, and then I would have a number there. The only thing is I don't know what the number is, but it's a number. It's an unknown number. Really, x is the unknown number, but if x is unknown, then the whole thing is unknown. And I can't do all the math yet. But it's some number. So I'm taking that number and I'm multiplying it times itself 3 times. Well, in order to show that, what it means, and this would be an explanation. You could just say it means take the base and multiply it times itself 3 times. That's an explanation also. But if you wanted to show it in the math version, like with the variables and numbers, it's gonna not really be easy. You could do that. It's taking the base, which in this case, everything in there is the base, and multiplying it times itself 3 times. We have base times itself 3 times. Just like this is base times itself 3 times. This one was actually supposed to be this. It got deleted. What's that mean? That one's a little different. I'm going to call on Colton for that one. What's that one mean? I got a new symbol now. This is not the same thing as an exponent. There's no, well, I mean, technically, I guess there is an exponent on the 16, but what does that mean? That was funny, guys. I don't know if you did that on purpose or it was a genuine reaction. Either way, it was funny. What's it mean? Doesn't mean to take 16 and multiply 16 times 16 times 16. Doesn't mean that. Anybody know? What do you think? It's not how much can go into, but that's closer. It's the opposite of what an exponent is. It means what number, so some number, let me use a question mark, what number times itself. And then the root tells us how many times that is, which is 4. Again, we're not multiplying 4 times 16. We never multiply the root. It means what number times itself 4 times. That's what the root means. How many times am I multiplying the unknown number? And then I have to get it to equal 16. So whatever's under here is actually the final answer over there. So that's what it means. So again, what number, what base you could say, times itself 4 times equals 16. So those root problems are the kind of the opposite of what an exponent means. You're solving a mystery in the root problems. All right, so that's a real quick review of what we need to know. What did we get out of here? 49.
Yeah, 49.
That's a normal Wednesday schedule, really, on Monday. So any questions on mainly that last one? Hopefully you get what the other ones mean. All right. Let's see, what else do we need to review real quick? This is not on the big quiz. Not on the big quiz, converting it from one format to another. You were already quizzed on that twice, so it's not on the big quiz. I don't know what that is or anything. That's the same thing. Kayla was here. Different Kayla. That was the work we did. Let's see what's in here. We did all of those. So the rules, obviously the rules are on there. Let me zoom out. So there are some practice problems. Why don't you try those? Because there are some problems similar to that. So we'll start the new material in like 15 minutes. But try those. Some of them are more difficult than others. The bottom right one is definitely the most difficult. But you should be able to do the other ones. I'll give you 2 more minutes. What's the first question you would ask yourself? Anybody have an idea? If you don't have an idea, then when I say it, you better write down, ask yourself this question first. Because a lot of times we do that, nobody answers. Some of you might know the answer, you just don't answer, but a lot of you don't know the answer. So when I give you the answer, you need to write it down. Just because I don't write it up on the board and force you to write it down, doesn't mean you don't need to have it down. Oh, that's right. If you have no idea how to do them, first of all, you're in a little bit of trouble. But second of all, at least make sure you have them all written down. You don't have to do that in a minute. If you can do the first three, you're in pretty good shape. The last one, I don't even think there's one that there was one on there that difficult, but I think I took it off. So you're more not to worry about that. But if you do it, I might make it a bonus. Or maybe I didn't leave it on there. One of them I left on there as a bonus. It might be on the new material. Actually, while you guys are doing that, I have something to practice out, which we won't get a bunch of time to work on it. So if we don't get to this, you can do it on your own. Came up with something just to practice all the stuff that we have done and we're doing today. So it's got everything on it. Are you ready? Put that phone up there. My seventh period must. Oh, is that period?
Oh, should I get that coach this one?
Can you knock on Coach Chestnut's door and tell him I've got something that I'm supposed to give him from work? As soon as I finish passing this out, we'll make some up. Boy, that stuff was left by a female player that she was told to give you.
Thank God.
Why is that your responsibility?
Because I'm the basketball coach.
All right. All right. Here, so can anybody answer the question? What is the first thing you ask yourself? All right, then write it down. Do I have the same bases anywhere in the problem? If you don't, there's absolutely nothing you can do except maybe multiply two numbers. Oh my goodness. You have missed so much. It's being recorded though, so make sure you watch it. So you ask yourself, do I have the same bases? If you do, then you can use some of the rules. Now, same bases can only work together. So I can't add any. So the rule, by the way, is going to be product rule. We're multiplying. And yes, I do have some of the same bases. So I'm going to add exponents. I can only add exponents for the bases that are the same. So for the 2 and the 2, I can add those exponents. For the x and the x, I can add those exponents. So my final answer will be that. Only add the exponents on the ones that are the same base. I'm going to give you like 30 seconds if you didn't know what to do on the other ones now to try to figure out what to do on them. Now I've done that first one. So again, if you don't have another base that is the same, you can't add any exponents. If it's a variable, then there's really nothing you can do. You'll just write it just like it was in the final answer. If it's two numbers, though, you can multiply the base numbers together. You just can't do anything with their exponents. That's not always true, but we're going to go with it for today. All right, so do I have the same base? And we're going to go to this one over here. How many of the same bases in that? Don't think? sure about that. I'm not going to call on for that. I'm going to call on Vicky, since you just came in. Do I have any same bases in that problem? This one over here. Yeah, I do. Yes, I do. M is the same base. So we don't, the bases, the numbers are not the same base, but they don't all have to be the same base. You just need anything that's the same. So M and M are the same base. So for the M and the M, I can write that base down and say 2 plus 4. What about the 2 and the 3 that are not the same base? What do we say we do with those?
Add them?
Not add them because it's a multiplication problem. You can multiply them. Now, if they had exponents on them, you actually wouldn't be able to do anything. So if there was a 2 on the 2 and a 3 on the 3, then we would just have to write 2 squared and 3 cubed. If there's no exponent, though, meaning the exponent is the same, actually, that's really the rule. If the exponent is the same, then you can multiply the numbers together. Don't worry too much about that. Just multiply them together. You're not going to have any of those other situations. So 2 times 3 gives me 6. You should have a bunch of those on the worksheet that we did. So make sure you have your worksheet out during that quiz, and you can probably find one on there that looks pretty similar to the problem. All I do is use the same types of problems. So this one's pretty similar. Again, if you didn't do that one, or if you did it, check and see now that we just did one pretty similar to it. Check your answer and see if you still think it's the correct answer, if you need to change anything. I'll give you 30 seconds. Gotta get something ready for something. All right. So, do we have the same base? Anywhere in there? We do, right? What is it? I think you said it right. I'm going to take your word for it. I'm going to give you the benefit of the doubt. N. Nothing else, though. No other same base. So the only place where we can add the exponent is going to be on that N. What am I adding? 1. Yes, that's the other thing we could have done. There's a 1 on that. There's actually a 1 on the 4 and a 1 on the 3 as well. You want to write those in. I'm not going to add them, but they're there. So N, and then 1 plus 4, because we add the exponents when we're multiplying the bases. And then we would say M doesn't have anything on it, so we just write the M squared. Now again, what do I do with the 4 and 3? Can't add any exponents, but what can I do? Yeah, we can multiply those. If they have the same exponent, then we can multiply them together. So, oh, well, I didn't do the math, but technically it doesn't matter which order you put the N and the M, but you would typically see the one with the higher exponent first and the one with the lower exponent second. I wouldn't really mark off for that. They might next year, I don't know. The last one is definitely the most complex one. I'm going to still do it, even though I don't think it's on the exit like that, unless it's a bonus. Same base, yes or no? Who am I going to go to now? Leah. Do I have the same base in there? Well, 5 and 3 are actually not the same base. Well, we'll be able to do something, but they're not the same base, so we can't do anything with the exponents. So do I have any same bases? What?
Well, you can all, this is hard to explain, but you can.
Which ones can I combine? Where am I going to combine exponents? So the M's are the same base with each other. N is only the same base with the other N. So on those, I can add those exponents. So the N, I can say 6 plus, what is it, -4. M, I can say 2 plus -7. 5 and 3, what am I going to do with the 5 and the 3? If I don't have the same base, I can do what though? those I can multiply and I'll wind up getting 15. So it'll be 15 times and then the n. And so when I do the math, I get this. So that's the correct answer, but what's the problem with that? Yeah, again, you will not be able to leave a negative in a final answer. Actually, we need to go over a simple version of that. I'll do that in a second. So, what I would wind up doing, and again, I don't think this is on there, but just to refresh your memory a little bit, these, the 15 and the n, do not have a negative exponent. So I got to remember, those are not negative. The negative 5 is only on the m. So I'm going to give you the quick version of this because I really don't think it's on there. So the 15 and the n are going to be on top, because remember, we need to make it a fraction. So they're going to be on top of the fraction. The m to the 5th will go on the bottom. We don't do the 1 over thing because we have something that needs to go on top. These two need to go on top, so it's not just a 1. But the m to the 5th still goes on the bottom. Let's do a real simple one. What if you get this? So let's just say we get 7 to the negative 4th. What do we do to make that a fraction? Colton, what do we do to make that a fraction? Or that take away the negative exponent? Anytime I ask you a question you don't know the answer to, you better be writing that problem down. You better be making notes on it. Because everything I'm doing today is on the quiz. Unless I tell you it's not like that one. If that one's on there, it's a bonus. How many people know what to do right now with the negative? Raise your hand. We're pretty sure you do. All right, so there are a lot of people who need to be writing this down. Lupita, wakey wakey. You need to know how to do these, girl. Colton, did you find it? All right. Who raised their hand that said they know how to do it? Somebody tell me. What do we do? This is where we need a 1, because the only exponent in there is a negative. There's no positive exponents. That's why we do the 1. If there's some positive exponents, we just put those on top instead of the 1. Same concept, though. Then we write everything else down on the bottom. So only the bases with the negative exponent go on the bottom. Anything with a positive exponent goes on the top. But you got to know how to do a simple one for sure, because those are on there, a couple of them probably. And it's not difficult. I mean, you just put a 1 on the top and a fraction line, and you put everything else on the bottom. So we did those now. We need to start the new material. Let me see if there's anything super critical. I'll probably just show you. I'm not going through how to solve like we did. There's some on that sheet that I gave you, but I'm not going through how to do. Next page. Oh, did that. Yeah, these things with the x's, like how to solve for x. We spent a whole day last week on it at the end of the week, and then we had done it 2 other days. So you need to know how to do those. You use again, that's 1 exponent. That's 1 exponent. That's obviously 1 exponent. Then you figure out what's the rule. Well, it's the quotient rule. So we said we take that top exponent. We show that it's just 1 exponent by putting it in parentheses. And then we say, well, I need to subtract, because it's a quotient rule problem, the bottom exponent. And then that has to equal the answer exponent. That's worth half the credit, just being able to set it up correctly. And then from there, if you do the math right, or the more math you do correctly, the more points you get. So you can practice, like I said, I think there's a few of those on there. We got to do something new, though. All right, so some problems that you will get. I didn't even cover that, but that's fine. No. Oh my goodness, it's not even on here? Say what? All right. Oh, looks like we're making it up. I want you to do the math on that yourself. Actually, here, let me make it. I'll make it even easier. Hold on. Do the math on that by hand, manually, the old-fashioned way. I want an actual number answer. Because do we have the same base? We cannot combine those in. We can't even multiply the 2 and the 4. Because in order to do that, you have to have the same exponent. So we can't even say it's 8 to the some power. Because if we were to multiply them together, how would we know which exponent to put? Do we put the 2? Do we put the 3? We don't know. So we can't even do that. Can't even multiply the 2 and the 4 together. So you'd have to do that one by multiplying it out the old-fashioned way, all the way out. So do that real quick. Hopefully you can do quick math with it. We know what 2 to the 3rd means. We know what 4 to the 2nd power means. So just multiply all those numbers out. I'll kind of get started for you. That's what it means, basically. All right, who got it? Anybody get it yet? Anybody fast multiplication? Anybody actually doing it? 2 times 2 is 4, times 2 is 8. 8 times 4 is 32. 32 times 4 is 128, I believe. Anybody get that? Yeah. All right, so that's what we get, right? 128. Here's the next lesson. It'd be nice if there were some shortcuts using all these exponent rules that we learned. And the exponent rules all are based on having the same base, which we don't have. But we can get the same base in those problems. What's another way to write 4? The number 4. As long as the value is still equal to 4, what's another way to write it? 2 times 2, right? 2 times 2 is 4. What's another way to write 2 times 2? No, just 2 times 2. If I tell you this, what's the way, and think about the lesson, Ron. What's another way to write 2 times 2?
2 to the...
No, how many do we have?
2 to the 2nd.
So that's the same thing, right, as 4. 2 squared is 4. So your lesson is, and it's really just a matter of practicing it, because you will have a question that tells you exactly what you need to do. You don't have to really figure it out. So you just got to practice doing it. I could take this problem and make it this. If I want the same base, well, 2 squared is the same thing as 4, right? And I now have the same base. I can't get rid of this squared because this is just the 4 part right here. Like I'm just taking what's in parentheses and replacing that with a number that has a base and an exponent so that I can have the same base as that. I still have to have that exponent out there also. So now I have 4 squared, and here I have 4 squared. It's just I've written the 4 in a different format. Now, what rule could I apply right there? Caleb, what rule could I apply when I have parentheses? An exponent raised to another exponent. What is it? So look at the ones that have the parentheses on there. Yeah, it's a power rule, right? I could say, well, this is really just 2 raised to the 4th because I multiply 2 times 2. So I have 2 to the 3rd. I change that to 2. I guess I'll write it out. To 2 times 2. So 2 to the 3rd times 2 to the 4th. Now I can just apply the normal O product rule, add 3 plus 4. So now I was able to simplify that down, even though initially I didn't have the same base and I wasn't able to do anything. Once I changed the base, I was able to get it down to something 1 base, 1 exponent. So that's what you're doing in the new lesson. Is you're just changing numbers into all the same base. The good news about it is they don't typically have real high bases, because if you get a base that's like, even if you just get it to be above 5, the numbers start getting really big really fast. So most of the time you're only trying to figure out numbers that have a base of 2 or 3 or maybe 4. I don't think I went over. There might be one that's above 4, I guess, but it's not real difficult. So, any questions on that concept? We're going to do quite a few of them, so if you're totally not getting it, don't worry. No questions? We'll see. Anybody writing still? Is that you, Betsy? Mm-hmm. Lee. You in? Good. All right. So we'll start easy. We won't even. It's not even a problem. I'm just going to ask you to change these into numbers that have the same base. Change those into two numbers. Again, they'll have the same value. They need to both be equal to 16, but I want you to write them with a base and an exponent, and the base has to be the same. So go ahead and change those. Don't sit there and just copy down answers like you're not trying it. First of all, it'll take you longer even if you do figure it out on the exit ticket. And I think time might be an issue on this exit ticket, or I'm sorry, this quiz. The more you practice, the faster you'll be in each problem. So all you're doing is creating two different numbers, so not 16 and 64. They will still equal 16 and 64, but you'll have a base and an exponent. And like I said, normally the base is not going to be real high, so just start at the lowest base and work your way up until you figure it out. At least that's the way I do it. Give it another minute and we'll start working on it. I'll show you the process I would use. Got it? Do you really? I didn't see it. It wouldn't be that. That doesn't equal 16. It's got to equal 16. This is the number. That's the value you have to have. That has to have the same value. 16 squared. Now, for that one, possibly, if you can figure out one. Anybody think they got it right? Not sure. All right, so it looks like we're struggling, so I'm going to go ahead and just get started. Then once I do one, you should be able to do it after that. All right, so I need the same base. Using that same base, I need to multiply it times itself until I get to 16, if that's possible. Just start at the first number. Start at 2. That's why I do it. And you go, is 2 times 2 16? Is it? And until you go over the number, you just keep going. Is 2 times 2 16? Is 2 times 2 16?
No.
Jeez Louise. 2 times 2 is 4, right? But keep going. Don't stop because I'm not to 16 yet. It might still work out. Is 4 times 2 16? Because I'm going to keep multiplying 2 until I get above 16 or I hit 16. 4 times 2 16. All right. It's 8. Is 8 times 2 16? Yeah, it is. So there we go. That's a base. How many times did I do it? What's my exponent on that 2? How many times did I multiply 2's? 4, right? Count the 2's. Multiplied it twice here, 3 times, 4 times. So that right there is 16. It's got a base, and it's got an exponent. Now, I may not be done because I need the same base on both of them, and maybe 2 doesn't work for 64. If it doesn't work for 64, then I'm not done. I got to try a new base. I got to come back and try 3 for both of them, or 4 for both of them. So let's see if 2 works for that. We already did 2 all the way up to 16, so we can just keep going. We don't really need to. I'll change it to blue even. You might want to do it all over again, just so you don't get confused, but I'm going to keep going up here. Is 16 times 2, 64. 16 times 2. What is it? 32. It's like doubling it, right? So that's 32. So nope, not 64, but again, I'm not done. I want to try it because I'm not over 64, so it might still work out. 32 times 2 is 64. Yes, it is. So 2 will work. I got to the number I needed both times. I got to 64 and I got to 16. How many times now? So again, the base here is still 2. What's my exponent on that 2? How many times did I multiply 2 there? Yeah, count the 2's. I already had 4 of them, 5, 6. So that's how you would change numbers into numbers that have the same base and are going to have an exponent on them. And the exponent will never be the same, or else you would have had to have had the same starting number, which would be silly. They wouldn't do that. All right, so now let's give you one. Again, the numbers can't be super, super high, so. How about this? That and that. I want you to give me numbers that have the same base. Yeah, same base, and they'll have exponents on them. And they have to have the same value as those 2 numbers when you have the base and the exponent. Oh shoot, I didn't. I will come back to it. All right, so I'll give you a couple of minutes again. Start at the lowest number. You don't need to start at 1 because 1 times 1 times 1 is just always going to be 1, so that will never be the answer. Let's start at 2. Work your way up. Give you a couple minutes. The math's not complex. You just need to make sure you can track how many times you're multiplying by the same number so you get that. I'll walk around, see how we're doing. Works. Yeah. It might work. Maybe, maybe not. Keep going though.
I'm not done. Stop.
Right idea, but how many times did you do that? How many knives? No, how many knives do you have? Oh, look at these. Who left that? Who went out and left for Willie? That's the second time he's done that. Second time he's done that.
Is he even here?
Is he here? Yeah, he just took the pass out like literally 10 minutes ago.
I wasn't here.
Well, whatever. I mean, you get it. But then he leaves the pass. Oh, I gotta go. Oh, it's Murray. I gotta go. I gotta go. He doesn't get a pass anymore. He's gonna get escorted if I ever see him.
I should go back to Untitled Chapter.
Probably. All right. So some people were on the right track. I can't remember if anybody. Yeah, somebody had the answer. So what did you come up with, Lee? Lee. Lee. Hey, wakey, wakey. All right. So I'm assuming you didn't do it. All right. You need to see it then. Did you come up with an answer? Nothing? Do you not want to share it, or you didn't come up with it? Was the answer, I don't want to share it, or I didn't come up with anything? You don't want to share it?
I didn't come up with anything.
Did you come up with an answer? Well, I know you didn't. Kira, 1 or 2? 1 means you don't have anything, 2 means you don't want to share it. 1 or 2? 1, you don't have anything, 2, you don't want to share it. 1. Bets up. What's your answer? Answer. Bets up shares. You don't have anything? What do you got? Close, but how many times did you do this to get that? So that's 2. How many 3s did you have to get that? All. So 2. So that's correct. All right, so Betsy got it right, so I'll share it with you. So she said, I'm going to start at, I don't know that she said this, but I would say this. I'm going to start at 2, and I'll just try the lowest number that there is until I see if it hits 9. Do we really have to do that, though? Is 2 times 2 times 2 ever going to hit 9? It's an odd number. 2 is always going to be even when you keep multiplying it. So really, we can skip over 2. So let's start with 3. Can we multiply 3 times itself and get 9? Oh, no. Can we? Yeah, right. 3 times 3 is 9. How many 3s do we have there? So our, let me put it right under that. So 3 squared works to get 9. Again, we may not be done. Like 3 may not wind up being the base because it might not work for the 81, but we know it worked for the 9. Now I'm going to go ahead and start all over from scratch. So 3 times 3 is not 81. That's 9. What's 9 times 3? So again, not 81, but I'm not over 81, so I can keep going. So I'll multiply times 3 one more time. What's 27 times 3? Hey, 81. Look at that. Again, the numbers are going to be low, so eventually, I mean, I don't think I go higher than 5, so you'll never have to multiply higher than 5 before you'll know if it works. So 3 to the what was 81? Yeah, 4 3s, right? 1, 2, 3, 4. So there you go. That's your answer. Is that the only answer? Why not? What else is the answer? Did you know? Yeah, you did it a different way, right? You probably didn't start at the lowest one, but you saw, well, wait a minute. If I'm just looking for a number times itself that equals 81, and it has the same base over here, well, there's not a number times itself that equals 9. I'm sorry, there's not any other 2 numbers that equal 9, but 9 with a base of 1 has base of 9. And I know that if I want to have the same base over here, I could say 9 squared. 9 times 9 is 81. So that's also an answer. Again, I don't care which one you put. I'm not telling you, well, actually on one of them, I think I do tell you to put a certain base so you'll know what number to use. That one should be easy. But if I'm asking you to come up with your own base, if there's multiple versions that work, that's fine. Just use one of the ones that work. Key is, though, this has to equal that number. 9 to the first power is 9. 9 squared is 81. 3 squared is also 9. 3 to the fourth is also 81. So the key is you just have to make sure that they equal whatever that number is when you multiply them out. All right, so that's on there. Then it gets a little trickier after that. So I give you, oh, what is it I give you after that? Oh, I give you a problem like this then. I want you to use exponent rules to change this problem into a final answer that has a base and an exponent. So you need to do what we just did. You need to come up with the same base for those two numbers, and then you'd have an exponent. One of them already has an exponent, one of them doesn't. So once you change it into another format, your final answer will be in the form of a base and an exponent. So write that problem down. Do your example. That is that form. Well, recently you were zoning out of here at the law. So we've already figured out that 81 is the same thing as a base. So we would change it to this, because we just figured that out on the previous screen. I'm going to give you one in a minute that we haven't figured out. And we would say, okay, well, using our rules of exponent, if we have the same base and we are multiplying, we just add the exponents. There you go. That's the final answer. That's how your answer will look on that problem. You will give me an answer in the form of one base, one exponent. You just got to figure out what that base needs to be. This one was pretty obvious. If this is the base, it's got to be the base there. There's no other base I can convert this to. I mean, 3 doesn't have anything that I could change it to. 81 does.
Are we doing a on one
So there's a big quiz on there, 100-point quiz. Yeah, that's the quiz day. And this is on there. So really quickly, let's come up with another one. I want you to change. Well, that's a good one. I could do it with variables, but I decided not to do it with variables. So it's only with numbers. I mean, there's not that many numbers I can use because I don't want to use super high numbers since you don't get a calculator. So let's go with, I want you to change these to a problem that had the same base and then simplify it down to one base, one exponent. Do this. Oh, Willy, Willy, Willy. I'll give you 30 more seconds. All right, so raise your hand if you think you understand what we're doing and you think you got the right answer. Kind of, sort of. All right, where you at? Good? 9, all right. Let's see, we just started. What about Joy's not paying attention? Joy, you need to watch this. This is brand new stuff, Joy. Lupita, where are you at? Do you got it? Or I ain't got it. So let's do this one again. It's the same process every time. If you follow this process, it will work. So when you do the math right. Start with the lowest number. If I tell, and I do tell you on the quiz, I say change the number, or I say Well, yeah, I still say change the number into a problem that has the same base and then simplify it, meaning give me one answer that has one base, one exponent. Start with 2. Well, can I use 2 to get to 4 if I keep multiplying 2 times 2 times 2? Well, yeah, I'm hoping you know that. 2 times 2 is 4. So that is 2 squared. Now again, 2 may not work out. It might not work for a number 32, but since I can't give you that many different numbers, there's a pretty good chance it will. So I could then say that's got to multiply times, and now I say, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, and times 2, look at that, 32. So it did work. What's the exponent on it? What's the exponent on 2 to get it to 32? Elias, what'd you get? That is correct. Again, count how many times you multiplied it. 1, 2, 3, 4, 5. That's what the exponent would be. So then, what's your final answer? Colton. Well, specifically, say it again. 2 to the 7th. Good. I didn't hear him say the 2 part. I just heard him say 7. That's why I was making sure. So now it's just a problem where we add the exponents because we've got multiplication. We got the product rule. I mean, I'm trying to come up with more challenging ones than the only thing that's more challenging if I give you a little bit higher number, but if I give you a higher number, I'm not going to make you multiply very many times, so it shouldn't be that difficult. The only other thing I will do on the quiz, I might give you a problem like this. So, and I'll do some of the math here for you. Oh, nope, don't want to do that. Let's see. I'm doing math in my head. That doesn't sound right. Is that right? Well, I'm going to do that. I don't think that's right. Oh, yeah, that was right. What in the world? That can't be. Oh, yeah, that is right. So if I give you this, for example, we change that one, the numbers are a little higher, so either we're going to multiply 2 times 2 times 2 a lot, which I'm going to go through that, even though clearly, why would 2 not work? Anybody tell me immediately why you know you can skip over 2 before I even try to do it with that 216? And I wouldn't know immediately that 2 doesn't come out to be 216 except for this. Why would 2 not? I know 2 is not going to work out. Yeah. What do you think? No, not because it takes too long. I mean, you could have numbers in the thousands and 2 could still be the base if it comes out to be. The hint is really down here.
It won't equal to 21.
Well, it doesn't have anything to do with those 2 numbers. It doesn't have anything to do with that number at all. I'll give you a hint. I know 2 won't work because of the bottom. Because if I need the same base on both the top and the bottom number, 2 is going to have to work for 36. But what did we just do with 2 that we know it doesn't work for 36? What number did we just get with 2? We did it a couple times. Like when we use 2 raised to a power, we just got a number that wasn't 36. What did we just get? 32, right? So there's no way it's going to work for 36 if it worked for 32. So I know immediately 2 doesn't work.
How would it not work?
Because if I get 2 times 2 times 2 times 2, 5 times, right? Equal 32. And then I multiply times 2 one more, that's not going to be 36. So yeah, I know immediately that 2 doesn't work because of the bottom number, not the top number. So I'd always start with the smallest number. All right. So does 3 work for 36? Think? What's 3 times 3? What's 3 times 9? So if I multiply that again, is it going to give me 36? So 3 doesn't work. What about 4? What's 4 times 4? What's 4 times 16? Is it going to be 32? Put it that way. Even if you don't know what it comes out to be. It's 4 times 16 going to be 36?
Oh, 64.
Yeah, it's 64. It's way above 36. So that didn't work. 5 times 5 going to give you a 36 at all? No, that's 25, right? What about 6 times 6? Hey, I think we got a winner. Once you get to numbers this high, you're typically going to be having smaller exponents. You're not going to make you multiply that out 7 or 8 times, considering you don't get a calculator. So we know 6 is probably going to work. So that's 36. What's 36 times 6? Take a guess. It's 216. Like I said, once you get to numbers that are above 5, maybe even above 4, you're not going to have exponents that are like 7 or 8. It's going to be exponents that are 2, 3, maybe 4, but on my stuff, it won't even be 4. So 6 to the third would be 216. But what can we do with that? Not done. We need one base, one exponent. What rule would we use? What's the rule for that when it looks like that? You see this, you should immediately know that rule by now. Yeah, it looks like a fraction, right? If you don't know it, you better be using your sheet today when you practice. I'm glad that this is the last one I'm going to do. There's another problem on there. I'll make a bonus that involves this same concept, but it's much harder. I doubt anybody will wind up getting it right. So that right there is the quotient rule. It says write the base, take the top exponent, subtract the bottom exponent, and that would be your final answer. All right, so you have a practice sheet. I don't care which practice. You've got 30 minutes to practice, which is a decent amount of time. If you feel like you need to go back to the basics, because there's a lot of points in the simple problems, so if you want to make sure you get those points, practice that. If you think that you're good with all of those, you can skip over all of those and go straight down to the new stuff, or the stuff where we had exponents in the final, variables in the exponent. Oh, there's what I was looking for right there. Yeah, that was it. So this is what's on the quiz that's going to be really difficult. Here, tell you what, copy that one down right there. The 4 times x plus 4, 8 to the 2x subtract 2. I'm going to show you at least how to do it, and then if anybody wants to give it a shot. Quiz. At least you'll have an example you can practice on your own, because there is one on the sheet like this. Practice one. So you can practice on your own. So I'm going to just give you the kind of what sort of is the answer. I'm going to zoom way in. You're going to still have to solve it out on your own, but I'll give you the first step. So I know 4 is 2 squared, but then all of that is raised to that power. And then I know 8 is 2 to the third. So all of that is still raised to that power. And then I know 2 to the 6th, we actually did that earlier. 2 to the 6th is 64, but that's still raised to the third power. So now I've converted it in the same copy. Well, yeah, you can copy this when you get back. Trade your phone out, please. So now, though, I still have to apply a rule where I say, well, I need to get this to one base and just one exponent, which, again, one exponent is going to have a variable in it, so it's going to have more stuff in there. I need to multiply the 2 times all of that. So 2 times x gives me 2x. 2 times 4 gives me 8. And then I need to multiply the 3 times all of that. So 6x subtract 6. And then I multiply the 2 exponents there. And give me 18. Now you're on a problem like what we did last class. This exponent plus this exponent has to equal that exponent right there. it's a multiplication problem. We have the same base, so we add the exponents, and we have to equal that. And then you solve for x. That's what the problem says, solve for x. Like I said, that's a bonus. I just put it up there in case anybody wants to try to work it on your own. If you do want to try that on your own so that you can get some bonus points, I'll look at it at the beginning of next class, Wednesday before the quiz. So this is just like what we did before, last class. Once you have the same base, you're just saying that plus that has to equal that, and then solve for x. And then what we did again, oh, that's not right. So that would be multiplying. Nope, didn't mean to do that. So we would just say there, well, actually, you can write that one down and try that one too if you want. This is one like that, I think, on your sheet. That's what we did last class. We already reviewed a bunch of the old stuff. So work on it. I'll walk around and help, answer some questions. Oh, let me stop the video. What would we do here? I do want to go over that. How am I solving for x in this? Just quickly, verbally. Anyway. All right, then. So this is what we did last class. I have the same base already, so I don't need to change anything. So if I'm multiplying, which I am, that means I have to say, well, this exponent, so it's the product rule. So that's all one number, remember, that is one exponent. That is one exponent. That's clearly one exponent. So it would be the first exponent plus the second exponent equals the answer exponent. So you set up an equation, just like I did right here and like we did last week. Where is it? Whoa. What? Here? What in the world? I just did one. What was it? Oh, yeah, there. So we set up well, actually, I didn't set up the equation. I'll set it up. So we would say 2x plus 8, and you can show that's one number by using parentheses, plus 6x subtract 6 has to equal 18. So that's where we set up equations like that when we solve for x. That's half the question, though, right there, just setting the equation up. So, all right, so I'll walk around. Actually, oh, did I do attendance? Let me see if I did attendance, and I'll walk around after I do attendance. So work on whatever you think is going to get you the most points. Each section's about equal, so the old stuff is worth about as many points. There's more problems on that, but it's worth about as many points as the section where you just do this. Actually, this is not worth as many points where you have to convert the bases to the same base. That's not worth as many points as the other stuff. So. That didn't work. There. Oh, why is it not? Is it not recording? Let me just walk out whenever we want.